Okay, so this is week one, quarter 3, math 7, and it is the homework for Wednesday. So it says circle your assigned pattern. So which one are we doing? Okay, so then okay, so then what's your total here? This is figure 1, figure 2, figure 3. Now reviewing from yesterday, remember n is a number of what? No. T of n is the total tiles. And by tiles, we mean like the little squares, right? So figure 1, figure 2, figure 3. How many total do you have here? Okay. All right. So if you look at this right here, the first point is 1, 4, 2, 6, 3, 8, right? Yeah. So let's write those points down. Did you write those points down? You should be writing those points down. Didn't we do that yesterday on Tuesday and also on Monday? So then looking at this, look at the part I'm highlighting in blue. You see how that's just added 1 each time? Yeah, that's just plus 1, right? Now, take a look at the part that is highlighted in yellow. What about that? Is that constant or is that jumping around like yesterday? Because remember yesterday we had plus 5, plus 7, plus 9, plus 11 and stuff. This one, it's constant, right? If it's constant, what are you adding by? Or what are you subtracting or adding by? 2, right? If it's constant, this is going to be a linear equation. A linear equation is when you have y equals mx plus b, right? Another way that we can think about this is that if it was t and n, it's t of n equals m n plus b. Like the number of figure is obviously going to change the total number of tiles, right? And it also always depends on how many figure you're using, right? Because it looks like the more figure you use, or like you go to higher number of figure, like figure 4, figure 5, figure 6, the tiles will increase. You have more tiles, right? Yeah. So this one is going to be a linear. So we know we're going to be using an equation something like this. Yesterday, when it was not constant, where like the y values, you have like a plus 3, then a plus 5, then a plus 7, then a plus 9, right? Even though in between them, it's a difference of 2, correct? But this is not constant. If it's not constant, it's quadratic. Quadratic means it's x with a square right there, okay? And yesterday, our equation was like t of n equals, it was like x n squared plus n plus b, right? Okay, so there's going to be a square. So do you see the difference right here between the two? Yeah. These are the two differences, okay? All right, so number 1, what would the next two figure look like? Well, you got figure 3. What do you think figure 4 is going to look like? How many squares are you going to have, or how many tiles are you going to have? So it will be what? What's your total number of figure for number 4? 10. And what about number 5? 12, right? Did you draw the picture? Okay, good. So then make sure you put 4, 10, 5, 12. Make sure you write that out. And make sure you label this as figure number 4. Can we label it properly, please? You know, she's a stickler, so let's just go ahead and label it properly. Figure number 5. Okay? Yeah. Now we create table 1, 4, 2, 6, 3, 8. Perfect. And then you went ahead. Okay, but you gotta label this. This is the x value, and the x value is figures. Right? This right here is the y value. And that is going to be the total tiles. Okay, so let's just make sure we label everything correctly. Write a recursive formula for the pattern. So your formula is going to be y equals mx plus b, right?
Yeah.
Now, we're going to go back to 4 and 5. Do you see 4 and 5? You can use technically any points of your choice, okay? You don't have to use figure 4 and figure 5. You could use the points for figure 1 and figure 2 or figure 3. So which 2 points do you want to use? Because it's constant, like the y is only adding 2, adding 2, adding 2. You can use the slope formula, okay? So which one would you like to use?
Figure 2.
Figure 2 and what else?
Figure 4.
Figure 2 is 2, 6. Figure 4 is 4, 10, right? You see the slope right here? To find that number here, the slope is y2 minus y1 over x2 minus x1, right?
Yeah.
Let's label this. This is your first point, so it's x1, y1. That's your second point, so that's y2, y2, x2, y2. Now I want you to plug in those numbers into this formula. So you have 4 over 2. 10 minus 6, 4 minus 2.
Wait.
y2 minus y1. y2. How are you getting this wrong? I mean, come on. You're just plugging numbers in. y2 minus y1. Right there. Right?
Yeah.
Well, x2 minus x1. Right there.
I understand.
I don't understand how you do that either. So next time it might be easier if you pick 2 points next to each other, like figure 1, figure 2. I don't know. I think you probably just did a 10 minus, well, you probably put x2 instead of x. You were supposed to do y2, not x2. So just don't make that mistake again. So then your m equals 2, correct? So let's replace it. So there's 2. Do you see that? Y equals 2 times x plus b. Now I need to find b. Do you see the b right there? You now need to pick a point. Which point looks easier, figure 2 or figure 4 to use? Pick a point.
1. Figure 1.
No, you already picked figure 2 or figure 4. Just pick one of the figures over here. The ones you're already using. This one here or this one here. Figure 2. Can we say that this is x and y is 6?
Yeah.
So this equal, where it is y equals 2, or actually, let's do it this way. Y, we're going to replace y with 6, correct?
Yeah.
What's x? X is, okay, 2. So 2 times 2 plus b. So what does b equal then? No. No. 6 equals 4 plus b. What's b?
Ten.
No. Try again. Don't skip any steps. Try. So what's our b? Pay attention. This is not a difficult thing. What is 6 equal here? Which is what? How do you get the b by itself? What do you do? So what's 6 minus 4? Do you understand that? That goes right here. You see that? Equation is y equals 2x plus 2. Okay, so when you talk about explicit and recursive formula, let's go ahead and use this part. Let's see. Okay, so what are the first figure? What's the first figure?
The
Hold on a second, hold on. What are the recursive formula and explicit formula for data's, what's the first one?
1, 4,
1, 4, okay.
2, 6. Wait, are we doing the entire thing?
2, 6.
Okay.
What's the next one?
3, 8.
3, 8.
Yeah.
One more.
4, 10.
The more points you have, the better accuracy it is, just in case, you know. 4, 10. That makes sense, right? N is 1, f of n equals 4, right? Because we plug it in, right? So the difference, we know that is 2. We said that, right? Between 6, 10, or 8, 10. So your formula is right here. F of n equals 2n plus 2. Isn't the same thing as y equals 2x plus 2? Isn't that what we did?
Yeah.
This right here. So, whoops, what happened? So your explicit formula is y equals 2x plus 2. So write that down for explicit formula. Do you see that right here? Did you see the explicit formula? So for your explicit formula, your explicit formula is just going to be y equals 2x plus 2, or you could do t of n, which is 2n plus 2. That will be your explicit formula, right?
Yeah.
So copy that right down. Then for your recursive formula, that's going to be different. Recursive, f of 1 equals 4, because it was 1 comma 4, wasn't it? Okay. F of n stands for the number of figures, right? Equals f of n minus 1. So it's one figure behind plus 2. I don't know how you want to really read that. F of n minus 1. So I really don't know how she expects you to know how to do that. So for your recursive formula, so you could do t of n is equal to t of n minus 1 plus 2. I actually don't really understand it either, but you know, it's fine. Okay, number 7. Usually the domain will be the x column. There's no column for x. X is horizontal. There's no column. Column implies up and down. Okay, well then refer to the table.
That's right.
Well, then you should say referring to the table, the domain will be the x column and but that's not what she's asking. She's asking you what are all the possible answers for domain and range, going to the graph, right? Look at the x. This is the x, correct? The x is referring to the number of figures. What is the smallest number of figure that you started off with? 1, but could also be 0. It could be 0. So it could just say from 0 to positive infinity. You have a million figures, right? Yeah. So you need to put domain is from 0 to positive infinity. Like you're including 0. Does that make sense? But it's between 0, 1, 2. Don't erase it. Just write on the side. 0, 1, 2, 3. So that's all the figures. Figures cannot be negative. You can't say negative 1 figure, right? Or negative 2 figure. That doesn't make any sense. Now the range is here. That refers to what? What does the range refers to? Total of tiles, right? What's the smallest number of tiles you started off with? Yeah, but it could also be 0, couldn't it? So we'll just say it's from 0, because figure 0 will have 0 tiles. So from 0 to positive infinity. Or you might want to ask her about this. It might be 1 to positive infinity because it starts with figure 1. And it could be 2 to positive infinity. I'll just put an or right there. I don't know if she wants to include 0 because technically it could be 0 because 0 figure implies 0 tiles, right? And on top, just put 0 figures mean 0 tiles.
Okay.
Does that make sense?
Yeah.
Okay. Give the domain range for this pattern. Okay, good. This looks good. You're the teacher. Write one question you would like to ask the class about these relationships.
I came up with a question, but it's really
What's your question? Just come. What is it? Well, then why would you even tell me about that? That seems like kind of a stupid thing to mention.
mention or not. I'm like trying to like.
Did you bother using this?
Yeah, but I didn't understand
What is a good question to ask about?
how the relations of the domain. Okay, fine.
You can use this one. What are the advantages and disadvantages of using recursive and explicit formulas? You can ask something like that. That could be a question. That could be one question. Or actually, another good, better question might be, what information do you need to create an explicit formula for a sequence? That might be a better one. We'll include 2, just in case she gets a little bit picky, okay? Oh. Yeah, I will help you with that.
This is right. She's upset at me for